Alright, this video is for how to subtract mixed numbers, especially when the first mixed number has a smaller numerator than the mixed number that you are trying to subtract. This makes it tricky because they're going to have to borrow or another method later on in the video in order to do this. So it gets definitely a little bit more tricky in this situation. So first and foremost, let's start off with really looking at what 5 2/8 really looks like. So when I have 5 2/8, that means I have 5 holes. So I have 1, 2, 3, 4, 5 full holes. And then in my 6th hole, I have only these 2 pieces. This is why it is 5 2/8. Now the 2/8 comes from that there are actually 8 pieces inside of this pizza or hole or whatever you want to call it. Could be a pie, could be pizza. I always talk about pizza just because I love pizza. So I mean, just, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 pieces inside, and that is coming from our denominator. So this is what we have in 5 2/8. Now the goal here is when it says to subtract 3 5/8, I want to separate 3 holes and 5/8 or 5 pieces from what we already have. So the concept of their idea here is really I'm Xing them out, or I'm getting rid of them. I'm taking them away, and then I want to get rid of 5 slices if I can. So here's what I have here. So I have 5 2/8 right here. Once again, I have my 5 holes, and then I have my 6 pizza that has the 2 pieces shown. Now I want to take away 3 5/8. Okay, so I'm going to start with just my whole numbers. I'm just going to get rid of 3. So 1, 2, 3, gone. So here's where we run into a little bit of an issue. I only have 2 slices, and I want to take away 5. Oh no, what now? Okay, this is with a roadblock that many of you are running into. Like, okay, I'm not sure what to do here. So what we have to remember is that in both of these pizzas, I have 8 slices. They're full. There are 8 slices here, and there are 8 slices in the next one. So I have more slices that I can give away. All that really means is that I have to dig in there and take them out. So I open up my box of glorious pizza, and inside I see 8 delicious slices of pizza, and I have to get rid of some more. So I want to get rid of 5 of them. So I'm going to start with my box that's already almost empty here. So I'm going to get 1, 2 slices. So I still have 3 more to go. So 1, 2, 3, 4, 5. Alright, so now I've taken away all of the slices that I need. So my answer is going to be, well, how many holes do I have left? So I have 1, hold on, 1 hole there. So I have 1 hole left. And then all I have to do is count up how many slices I have in my box. So I have 1, 2, 3, 4, 5. So I have 5 slices left, and the denominator 8 stays the same because there were still 8 slices in that pizza. Alright, so drawing pictures is wonderful. It's really helpful, but it does take a long time. So we are trying to get our kids pretty fluent with this as well. They're always more than welcome to draw a picture if they have to. However, mathematically, there's 2 options of how we can solve this problem. Option 1 is to convert it. And what we're going to convert them to is actually improper fractions. Alright, so this is from the other lesson that we just went over. So to do this to an improper fraction, I'm going to take my whole number, 5, I'm going to multiply by 8, because that's how many pieces are in every single one of those 5 boxes. So 5 times 8 is 40. I'm going to add on my numerator, and I'm going to end up with 42. So I have 42 slices altogether here, and they're out of 8s. Now for down here, I'm going to do this one. So 3 holes times 8 each. 3 times 8 is 24, plus the 5 slices up here is 29. So now this actually becomes quite easier. I have 42, I gotta get rid of 29, and I want to know how much is left. So in case you just need to do this as a quick scratch problem on your whiteboard, on your table, I'm just going to do a quick 42 minus 29 and find out how many pieces I have left. So I'm going to borrow from that 4, make it a 3, and just like we always do in class. So I have 13 pieces left. So what this means is I have 13 slices and 8 can go into each box, so 13 eighths. Now, this is an improper fraction. We want to change it back to our mixed number. So I'm asking myself, okay, I have 13 slices of pizza. I can stick 8 of them into a box. So I know I can fill up one whole box with 8 eighths. Alright? So I'm thinking, okay, 8 eighths is one whole. So what could I add to 8 eighths to get me back to this 13 that I have left? So I'm thinking, okay, 8, 9, 10, 11, 12, 13. I count 5. I can add 5 more to that. Alright, so this 8 eighths is the one whole. And then I have 5 eighths left. So my answer is 1 and 5 eighths. Okay, so there's another option for you. Convert to your improper fraction and then convert back to a mixed number for the end. So as long as we get our answer to be in a mixed number, we're going to go. Another way is that we can borrow. Most kids in class definitely chose to do it this way or try it this way today. I think it's a pretty logical way to do it, and it's starting to click for a lot of us. So we have to understand what we're borrowing, though. So if I only have 2 slices and the 2 eighths, and I want to take away 5 eighths from the number down below, I'm going to have to go into my whole pizza boxes and take some slices out again. So if I go into my box, in one of my boxes, and take some slices out, I'm actually borrowing from my 5 wholes. I'm not going to have 5 whole pizzas anymore. I'm actually going to have 4 whole pizzas. Now, when I dig into one of those boxes, I know that one whole is 8 eighths. And I know that because of the denominator 8. Okay, so I open up a box. I'm going to use those pizzas now. So if I combine that, I have 4 wholes left, and I'm going to have 10 slices and 10 eighths. Now that I have that, I can easily go ahead and subtract. So I start my fraction. I have 10 eighths minus 5 eighths. 10 minus 5 is 5. The denominator stays the same. And 4 minus 3 is 1. So answer 1 and 3 eighths. We're going to do a quick practice one, show you another variation. I'm going to use the converting first. So in this situation, I'm going to do 6 times 9 is 54 plus 1. I have 55 ninths. And I want to take away 2 times 9 is 18. 18 plus 3 is 21 ninths. So what I'm looking here is 55 minus 21. This is how many pieces I'll have left over. Alright, so we're going to have 34 ninths as my answer. Now I wish I could leave it like that, but I have to convert it back. So this goes back to, like I said, the other lesson. What I'm really doing here is 34 divided by 9. Okay, if we know our math facts, we know that the closest I can get is going to be, let's see, 3. Because 3 times 9 is 27. I almost could get to 4, but I'm short just a little bit. Alright, and so I'm going to have 7 left, so a remainder of 7. So we should know from the other day's lesson that this means that I have 3 wholes and 7 pieces left. Denominator stays the same. So the answer is going to be 3 and 7 ninths. Now the borrowing method. So let's go ahead and borrow from that 6 again. I'm going to get 5, just like anytime you borrow from a number. Now when I borrow, I am getting 9 pieces this time. And the reason why it's 9 this time is because my denominator is 9. If my denominator is 9, I'm getting 9 full slices in that box. So now this now equals 5 and, if I add the top, 10 ninths. And of course 2/3 is, or 2 and 3 ninths is still the same. And I'm going to subtract this now. I like to start with my fractions. So 10 ninths minus 3 ninths is 10 minus 3 is 7. So 7 ninths. And 5 minus 2 is 3. And I have the same answer, 3 and 7 ninths.